In this video, we are going to look at Pascal's triangle and the generalization of binomial expansion. We are assuming you have the basic knowledge about counting combinations and the binomial theorem. So, binomial coefficients have many interesting properties. Perhaps the most familiar one is Pascal's triangle. It is a numerical array where each entry is equal to the sum of the two numbers appearing diagonally above it. Notice that each entry in Pascal's triangle can be expressed as a binomial coefficient, and the relationship just described appears to reduce to a simple equation involving the coefficients where n plus 1 choose k is equal to n choose k plus n choose k minus 1. The second property of Pascal's triangle is that you may notice the pattern for the sum of the first row is 2, second row is 4, and then 8, 16, which is a pattern can be summarized as 2 to the power of n. And this can be proved by using the binomial theorem by letting x and y equals to 1. The last property, perhaps is the most obvious one, comes from the fact that the triangle is numerically symmetrical, which can be expressed in a mathematical way where n choose k is equal to n choose n minus k.
So in terms of the next worked example, we will be finding the binomial expansion of a plus bx to the nth power, where n is a negative integer for approximation. Now the question is f of x equals 2 minus 5x to the negative 2 power. And given that x's absolute value is within 2/5, and further in the question it says find the binomial expansion of this function f of x in ascending powers of x as far as the term in x cubed, giving each coefficient as a simplified fraction. So let's just be aware of that. And as for how to solve this problem, we first sort of split it apart so that it's easier for us to dissect and expand binomially. And continuing with this, we get 1 plus negative 2. It's basically just subbing it into the binomial expansion formula. So in terms of the arithmetic for this, it's just basic multiplication and addition, and it shouldn't be a big problem. So it simplifies to 1 plus 5x, 75x squared over 4 plus 125x cubed over 2, and then so on and so forth, because we're only required to give it to x to the cubed. And further simplifying this argument, we get this 5x squared 16 plus 125x 8 plus ... And if we write it out nicely into mixed numbers, we get the following. For our final problem, we're still going to be doing binomial expansion of a plus bx to the nth power, but this time we're doing it where n is a fraction for approximation. Now, the rules still apply, including it's up to and including the terms in x cubed, and then we should simplify each term that we get. Now let's proceed with the problem. we know that the restriction for the absolute value of x is 4/9. And now, starting with the problem, basically rewrite 4 minus 9x in another format that's easier to start binomially expanding in. And as for the above, we put it here. So in terms of this, you just insert it into the appropriate formula given. You just have to know which formula it is, and it is explained above. 3 factorial. And then for questions like these, you just have to pay attention to your arithmetic procedure. It's nothing really mind-boggling. It's just that you have to be sort of careful with your calculations. And I won't be walking over that because it's relatively simple if you're watching this video, but this is what you get over 1024 x cubed plus ... because it only requires you to go up to x cubed. And then if you simplify this from the above, that is a very ugly 6. This is a 6. Wait, okay, never mind. And then minus 729, negative 729 over. So that is the answer to the problem.